Welcome. In this session on natural deduction, we'll consider a specific set of function symbols and a specific set of predicate symbols, and we'll develop two models for these. Let us suppose that our set of function symbols are I and S. And let's suppose that our set of predicate symbols are Q and R. And let's suppose that I could be anything, S could be anything, Q could be anything, R could be anything. So let's suppose that we have two models of these. We'll call these model 1, model 2. So let's call this model M1. And we'll think of this as binary operations. The first thing we have to do is specify the domain of discourse. If we're thinking, well, let's implement binary logic with this, then our domain of discourse would be the symbols 0 and 1. And these are the objects. We would then have to specify the nullary functions. And in this case, it's I, and because we're working in a model, we'll superscript I with a model. And we'll say I of M always returns the element 0. And then S, let's think about S as being the successor or the next one. And we could define this in two ways. We could say that S in the M of a term equals, by definition, we could say that this is T plus 1 modulo 2, or we could define this in terms of the specific mappings. We could say that S in this model takes a 0, and then in mathematics, when we put a bar on the right, a bar on the arrow, we're saying it takes this object and maps it to this object. We could say S maps 0 to 1, and S maps 1 to 0. That is, we can either provide a rule for the function, or we can provide an enumeration. Then we have to interpret Q. So let's suppose that we're interpreting Q in this model, and let's suppose we say, well, let's make that all of the even numbers. And in that case, there's only one even number in the domain of discourse, so this would be a set 0. Now, observe that we can't make this just the 0. This has to be a set. Could it be a set of everything in A? Yes. Could it be the empty set? Yes. We also need to have a model of R, and let's suppose that in binary logic we're thinking that the symbol R is going to map to all of the odd numbers, and so we could say that R is 1. Well, there are an infinite number of models. Let's suppose that we have a second model, and we'll call that M2, and let's think of this as elementary base 4. If we're thinking that we're going to model base 4 arithmetic using these logical symbols, then our domain of discourse is now going to be 0, 1, 2, and 3. And we might say, well, rather than starting at 0, let's say we'll pick 0. So let's suppose that we're going to say that the index function gives us 0. And let's suppose that we say that the successor function, we could put a defined, and we could put a defined here. So now S of a term, we'll take the term plus 1, and now this will be modulo 4. And if we wanted to, we could also enumerate these because the set is small and finite. Now suppose that we're going to change the way that we're going to model. Instead of modeling these as even numbers and odd numbers, suppose that we have a different model in mind. Suppose that we say that in model 2, this Q models the numbers that are the first half of the set. So let's say that it models 0, 1. And then let's suppose R in this model is now the set 2, 3. And each of these is a model according to the definition of model. That is, in each one we're defining a domain of discourse. We have a nullary function for every nullary symbol in the set script f. We have one unary function in the script f, and we've defined it. And we then have defined each of the predicates, and in this case we're imagining unary predicates, and we've defined each of them. Now we observe that if we have logical statements, that the logical statements are going to have different truth values depending on whether we pick this model or pick this model. So in subsequent sessions, what we'll do is we'll start to look at the relationship between models and formulas. And we'll go both ways. We'll begin with a model, and then we'll ask what formulas are true or false in this model, and then we'll look at formulas and ask what model could make this formula true or false.